right.
Okay, so we've been doing problems, like this for a while now, and your goal is to figure out 4 to what power equals 64. And maybe by now you just know, you say, okay, I've seen this
It's
that
4
many
to the
times.
third.
Exactly. So there's your answer. The next problem is very similar, different structure though. The goal again is to write 64 as 4 to some power. We know that that is 4 to the third power. And if you recall from our previous lessons, you take that exponent and you move it in front. So it becomes 3 log base 4 of 4. These are the same. 3 times 1 is 3. There's your answer.
All right. I'm gonna get the Desmos Scientific in case we need it.
Yeah, definitely. I'm sure there'll be calculations here. The nice thing being multiple choice is we'll be able to just confirm all those values. Okay, the this does not have a. So there's no there's no question. There's no like sort of instructions here. If you go to your calculator and you type in e to the third, which I'd like you to do, I think that will tell you what the result is. But boy, they sure don't.
It's gonna be C.
Let's see. Yeah, interesting. I didn't really give you much there to go off of. Normally it would say solve for the value or use your calculator, but not this time. Okay, log of x plus log of x. If you recall, when there's a sum, it becomes a product, x times x, or log x squared.
Log x.
And this equals 2. Now, this is kind of our first problem. There's a bit more to do here. So again, that sum becomes a product right there.
All right.
Okay. Now, there's really a base 10 here, and we can undo the log with the base, so 10. On the left side, it becomes x squared. On the right side, it's 10 squared, which is x squared equals 100.
So the answer would be like, wait, we're on number 4.
Yeah, we're trying to, we need to undo the square. Do you remember how to do that?
I think so. I mean, like, I feel like for this one, like when we're undoing the square, we have to square root everything, obviously. That's
Exactly.
one thing.
Yep, that's it. Take the square root of both sides. If you're not sure the result, go ahead and use that calculator.
That will be 10.
There you have it. All right, so they're getting just a tiny bit more complicated. Okay, so first thing in this problem is to take the exponent and put it here. So that becomes log x squared minus log x squared plus log 2 over x plus log x. Okay, now we've not really looked at one this complicated, but the thing is that if it's positive, it goes in the numerator. So the first x squared is going to go in the numerator. If it's negative, it goes in the denominator. So the the second x squared is going down here. If it's positive, it goes in the numerator. And if it's positive, it goes in the numerator. Okay, and this maybe looks more complicated than it actually will be here once we start simplifying, but the idea is if it's positive, it goes in the numerator. If it's negative, it goes in the denominator.
All right.
All right. So the should kind of rewrite this a little bit here without all the lines. I'm gonna write x is x over 1 squared here on the bottom. Okay. Because there's an x squared in the top and the bottom, they can cancel.
All right.
The x here on the top and bottom, you got an x on the right, top, bottom left, they can also cancel. All right, so this becomes log 2 over 1 over, there's really a 1 on the bottom. And 2 divided by 1 is 2, divided by another 1 is 2. This is really the log of 2.
All right.
So now you go to your calculator.
All right.
No way to do it otherwise. You have to see what that becomes.
It's gonna be 0.301.
Okay, looks a lot like A,
Yep.
so we'll go with that.
All right.
Great job on that. Okay, so next problem here, kind of standard, we get through a bunch real fast and then they kind of slow down a little. This one, here's number 6. All right, so we didn't really talk much about this. There is what's called a change of base formula. And it simply looks like this: log base b of x becomes log of x over log of b. It can also be written as the natural log of x over the natural log of b. All right, so in your problem here, it's log base 3 of 45. This becomes log of 45 over log of 3. Or if you prefer natural logarithms, natural log of 45 over natural log of 3. In either case, it's a full calculator problem. You have to go to the calculator to either put this in or this in, and you could do them both just to confirm that you get the same answer, but they are identical. So let's do that here as well. My side.
So I'm putting in the fraction, right?
Yes.
All right, just making sure.
Some calculators will allow you to enter it exactly here. But not, I don't think this one does.
Yeah. How exactly would I insert the ln exactly? Because I think I did something wrong with typing it because it wouldn't show my answer.
You can literally just type ln as ln. Let me show you that here.
All
You
right.
just type with parentheses is always good to indicate your argument is the number.
All right, there we go. I fixed it.
Okay. What did you?
I got C.
It is C. Good. Yeah, so I'm just going to snip this in case you want to look at it later. All right. So yeah, you see that it gets you the same result. Very good.
Yep.
All right. Number 8. 8 here. No, number 7. Don't want to skip number 7. All right, so we looked at a problem like this earlier. This is a difference here. Difference becomes becomes a quotient. Almost said product. Log base 4 of x squared. So the thing inside parentheses goes on the top over 4x minus 4 on the bottom equals 0. All right, now if you recall, we use the base this time is 4 on both sides of the equation. The base undoes the logarithm. So this gets undone. And so you have x squared over 4x minus 4 equals 4 to the 0.
All right.
So 4 to the 0 is 1. So this is x squared over 4x minus 4 equal to 1. And from here, you have to cross multiply. So we're
Great.
going to multiply and just reframe it here. 1x squared on the left equals 1 times 4x minus 4 on the right. So this becomes x squared equals 4x minus 4. And then you move those terms over.
All right.
So you have x squared minus 4x plus 4 equals 0.
Okay.
And then you have to factor. You have to factor. You should find two numbers that multiply to 4, but then add to negative 4. So they have to multiply to 4, but add to negative 4, which means they're both negative.
All right.
What would those be? What multiplies to 4 but adds to negative 4?
-2.
And what's the other one?
Just +2.
Okay, so these do not multiply to 4. They
Oh,
multiply to
sorry.
negative.
It would just be -2 and -2.
There you go. Small difference, but important.
Yeah. So that so the -2 would be our answer, maybe.
You have to set each of those equal to 0. So you want to be careful there, especially on the multiple choice, because
Oh yeah.
all of the possible wrong answers could be there. So
Yeah.
what is the value of x in both cases?
2.
It's 2. Now, normally we check, but there's no issues with either of these numbers because there's no chance they're going to become 0 or negative. So looks like x equals 2 is your answer. Any questions on that before we move to 8?
No, I'm good.
Okay. All right. Okay. You've got a sum here. What does a sum become in logarithms?
I don't remember.
Okay, go back and look at number 4.
Okay. Oh, they become fractions, right?
I'll scroll up and show you my notes here. Maybe you
Yeah.
didn't get that down.
Sure.
Okay, a sum becomes a
Product to
product.
multiplies.
Yes, so you multiply what's inside parentheses.
Okay. So x times 2, basically.
Well, the first one is x, the second one is x plus 2.
Okay.
So you're taking x and multiplying it by x plus 2. All right. How do
All
we
right.
undo the question?
I just said all right. I'm
Okay,
listening.
good. So how do we undo the logarithm?
Put 2 in front of it, and then
Yes.
Yeah.
What about the other side? Anything there?
Yeah, same for the other side, it becomes 2 to the power of 3.
Good. So this is x squared plus 2x equals 8. Well, we're going to move the 8 over, so it's x squared plus 2x minus 8 equals 0.
Okay.
I'd like you to try factoring this one. So you're looking for two numbers that multiply to -4, but add to +2.
All right. That add to 2, what? I heard add to 2 and
Multiply to -8, but add to +2. So it's always multiplies to the last number, adds to the middle number.
uh so like 4 times 2.
Yeah, but that doesn't multiply to -8.
Oh, sorry, -4. And no, wait. Actually, if you want, it would be -2 and +4.
Yeah, you have to go through all the progressions and make sure you got the right one. All right. Now from
Yeah.
here, you have to set each of these equal to 0. X plus 4 equal to 0. X minus 2 equal to 0.
So x would be -4 and +2.
And now we need to check. And
Yes.
specifically the negative one is the one that sort of should be like, okay, better check that and better figure out, what's going on there. Is that one okay? So we go back and look at the original. Can you take the logarithm of a negative number?
Can I do take a? I'm sorry, I spaced out.
Are you able to evaluate the logarithm of a negative number? Like, and if you're not sure, go to your calculator and just type in log of -4 and see what it says. Does it give you a result?
Nope, it's nope. So the answer would just be 2.
Yes, this other one is considered extraneous.
Yeah.
Okay. All right. Let's take a look here. We got number. Okay. Good news is we're all done with logarithms for now. But they'll probably come up here and again. But we got 3 or 4 problems that are back to exponentials. So if you recall here, whenever you have two bases, you want them to be the same. So you really want to make this 64 into 2 to some power. 2 to some power. What would that be?
Okay, so I um hmm. Well, 64 divided by 2 would be 6, right? No, wait, not 6. I was thinking of something else. Hold on. 64 divided. Okay, 64 divided by 2 is 32.
So you're not dividing though. Remember, it's 2
Yeah.
to some power. Like you did this in the very first problem. I said, what is 64? And you said, oh, it's 4 to the 3rd power.
Oh,
Well,
yeah. So it would be 2 to the 6th, I think.
there it
Yeah.
is. So this is 2 to the 2x plus 2 equals 2 to the 6th.
Yeah.
Right. So
But
you
we don't
see,
have a 2 to the 6th for our lovely selection of answers. So
that's right. You have to, but when the bases are the same, you set the exponents equal. Base is same, exponents equal.
all right.
2x plus 2 equals 6. All right. Could you try solving that for us?
Sure. The answer would be C.
Let's see. Good. Lots of twos.
Yeah, we're getting a lot of twos today, aren't we?
Yes. All right, so number 10. 10. So just like before, you want to write 27. The number on the right is 3 to some power. 3 to some power.
All right.
What might that be?
What isn't 3 to the isn't 3 cubed 27?
So you're right. 3 to the power of 3.
Yes.
Now, since the bases are the same, what can you do with the exponents?
We can dang, I always forget that word. I was gonna say factor them, and I'm like, no, because
We will be doing that in a bit, but and I'm not necessarily worried about you giving me the exact right words. I'd like to hear something in the kind of the right direction of what to do.
well, we can now solve. We can now like put them together in a problem, so we
Yeah,
can
so tell me what to
solve
write
it.
down here. Yeah, tell me what to write next. That would be,
X squared plus 2x equals 3.
yes, very good. And then you subtract 3 from both sides. So that's another way we can do this, Ivana, is if you're like, hey, I don't know the right word, but I would know what you should write. Like you can tell me what to write. That's another way to kind of answer my questions.
Okay.
So this one does have to be factored. And just like before, you're looking for two numbers that multiply to the last, but add to the second number.
-3 and +1.
X minus 3, X plus 1. Okay, if this were correct, then it will FOIL to this, but it does not.
Yeah.
-3 plus 1 is -2. We want +2.
Oh.
So
Okay.
what change should we make? Because they do. -3 and 1 do multiply to -3. They have to
Oh.
add to +2.
Oh, so we would change it to a -1.
And what about the -3?
We
Can
make
you
it
change it?
positive.
Yes. There we go. Set them both equal to 0.
So now x will equal -3 and +1.
Yes.
So the
And
answer would be 1, right? Because negative numbers are usually what's the like
well,
unidentified.
they're extraneous for logarithms, but is this a logarithm problem?
No.
So you can't apply those rules. It'd be like me applying figure skating rules to golf. It probably wouldn't go well.
It really would. I don't even understand the rules of golf, and I don't.
So keep that in mind here. Like the reason you might exclude it is because of something to do with logarithms. There are no logarithms here.
Mm-hmm. All right. So this is the first problem where we got two answers, basically. Like,
Yeah, for in a while, yes.
yes. Oh, okay. 11 is very interesting.
Let me get the. So 11 is one of those problems where we've actually solved a problem almost identical in number 1. Could you look back at number 1 and see what similarities there are to this?
It's the same thing, except instead of a 64, it's gonna be a 63, which means it's gonna be a decimal
Well,
answer.
think about how close are 63 and 64.
Very close.
So which number here is really close to 3?
D.
Yeah.
Easiest problem solved. No work need to be shown.
Yes, well, there is a way to do it, but this is, it's so close. There's no reason to do that. All right, we got a little lucky there, but for number 12, we unfortunately do have to. Well, I take that back. You actually can kind of estimate these reasonably. So 10 squared equals 100.
Yeah.
Do you agree with that?
Yes, I do
And
agree with that.
101 is pretty close to 100. I mean, it's not, if you had $100, $101, you're more or less the same. Now 10 to the 4x, well, that's a little bit different than 2, but is there a way to make 4x equal to 2?
Yeah, you divide by 4 first.
Good, so x equals
2. X equals 2.
Try again.
No, wait, I'm sorry. I was thinking of 2 divided by 4. It's gonna be 0.5.
It is.
And so the answer is A.
It is A. And we can use that approach on some, not all problems. Some meaning, the ones that kind of work. Now, if this were like 125, that wouldn't work. But
All
because
right.
it was so close to like a nice number, right, you can do it that way. All right, ready to take a look at the next one here? All right, so it says to expand. We're gonna actually just kind of write it in a nicer form here. X squared plus 6x plus 9, x squared minus 9.
All
Can
right.
you remember how to factor either the top or the bottom? Do any of those look familiar to you?
Okay, so the bottom's a perfect square.
Yeah, bottom's called difference of squares.
Yeah, sorry, difference of squares. I always get those two terms mixed up all the
Yeah.
time.
Well, thankfully, math isn't really about vocabulary.
Thankfully, yeah.
A lot more students would struggle because maybe the words don't mean much sometimes. You remember what to write for the bottom?
X plus 3 and x minus 3.
Very good. Now on the top, you're looking for two numbers that multiply to the last number, 9, positive 9, but add to the middle number, positive 6.
Okay, so x plus 3 and x plus 3, yeah.
Okay, do you see any cancellations? Anything that's the
Yes,
same on the top and bottom?
x plus 3.
Good.
There you go.
Okay, we're doing great here, but notice our answer is not there. We're down to log x plus 3, x minus 3. We did this in an earlier problem where we turned something into a quotient. Do you remember what becomes a quotient?
I think so.
Okay. Can you tell me what to maybe write? I'll just throw that out there.
Yeah, I think you have to write like log x plus 3 over log x minus, oh, sorry, or is it log minus?
Yeah. So the most common way to write it is from the left to the right here, where you say a difference becomes a quotient, but the quotient always goes backwards into a difference.
Yeah. So the answer would be, or we did not solve it out yet. I'm gonna.
Well, one of these does match up to what is given in the answer space there.
It would be A.
Yeah, it looks like A. Good.
We love A.
Yes.
All right. Port of the teens.
Yes. All right, the way to write this, there's no way for me to, well, I guess I can give you an example problem. So let's say it was 5 to the x equals 8. The answer is log base 5 of 8 equals x. Could you attempt to mimic that for this problem?
Okay.
See what you come up with.
Hmm. For this one, I feel like the closest power for it to work a little bit would be 6 to the first, and then I'll just go from there, maybe.
Are you seeing my screen? Do you see what I've written down here in the lower right?
Oh yeah.
Okay. The what I'm giving you is the same thing, but just different numbers. Like I'm trying to get you to see, well, where does the 5 go? Where does the x go? Where does the 8 go? So that you can use that to try to answer this problem.
Okay. I got a better view now. Okay. Long- Okay, that's okay. So I wrote down what you showed me. I put in 6 where 5 is. I put, so it'd be like log, so I did like the same thing that you wrote down.
Okay.
So the answer would be B, right? Like from the way it's written down.
Exactly. Yeah. And so the mapping of the things, like even though it's x and number, like it doesn't have to be. And you'll see that in the next problem. The next problem, it switches like where the number is and the letter is, but it's the same mapping. Like whatever is in the base comes down here to the base of the logarithm. Whatever the exponent is comes to the right side of the equation. Whatever's on the right side of the equal sign comes over here. So I'm going to snip in the next question here, and it is really similar. Give this a try, please.
All right. The answer would be C, right?
Log base x. Yes, you got it. Okay. So we're on to 16. There's a good chance we'll finish this today, which I'm sure will be very good. We've been doing some problems like this where the number on the right was a power of 4, and that that's not the case here. Like there's no power of 4 that gets you close to 200. Although you could sit here and argue that maybe 256 is kind of close. I would say it's a little too large, but um, that's kind of at your discretion. Now, to get the variable out of the exponent, we've been using logarithms, and the more common one to use is the natural logarithm. So we're going to take the natural logarithm of both sides, and what that does is it brings the x plus 2 out in front. So x plus 2, natural log of 4 equals natural log of 200. Is that okay so far?
Yes.
All right, now we're going to divide both sides by the natural log of 4. So this becomes on the left just x plus 2 equals the natural log of 200 over the natural log of 4. If I'm writing them separate, it means they have to be separate. Like there's no way to reasonably, like you can't divide these, was what I'm saying. They just have to leave it as is.
All right.
So now the last step here to solve for x is to subtract 2 from both sides, but there's nothing to subtract 2 from, so you just have to leave it off to the side. This is, this is why we like that Desmos calculator, because you can just enter this in. So go to your calculator, enter this in.
The answer is D.
Okay, I agree. Very good. Okay, 17. Oops, I didn't want to do that. It's going to mess up the recording.
We're having technical difficulties.
Yes. So the next problem here is more of a chemistry problem, but yeah, snip this in here. Okay. So they're the hunt, which they really meant hint.
Oh my god, my teacher made a spelling typo.
Yes.
I didn't know that. All right.
All right. So the answer here is that the pH, which is what we're trying to find, is minus the log of this number here, the 2 times 10 to the minus 4. So this is all you have to do to answer this question, to be able to put this into the calculator.
All right. So I'm just gonna have to insert that into the Desmos scientific.
Exactly. Exactly.
So it would be. Hold on, I forgot the negative. There we go. Fixed it. So the answer would be B.
And you may
Yeah.
recall that in chemistry, pHs go from 1 to 14, or I guess they even go to 0. So good, very good. All right, here is another problem for us to look at. It says after 5 hours, an initial bacteria population of 100 members has increased in size to 500 members. Determine the exponential growth rate of the colony of bacteria. So the formula we're using is PAT. PAT. So P stands for the initial amount. So in your problem, that's 100. A to the power of t. So we don't know either of those values, but we know that later on, A is the later amount, which is 500. And we know that this happens in 5 hours. So t is some sort of time or 5.
All
Right. So we have to just solve for A. Now, because it's a multiple choice test, you could, for example, try these numbers, but we're going to do it the correct way, which is to divide by 100 on both sides. 5 equals a to the 5th. And let me just double check this because I don't see any answers here that look like they're going to work. Why would they do that? 5 numbers.
They set us up on purpose.
Yeah. 5 to the. Huh. So let me do it another way. I think they might have meant pert. That's your log of 5 out of 5. There it is. Okay, so they actually meant pert, not pat, and we would have no way to do that. So let me just unfortunately have to reset here. A equals P e to the RT. That's pert, and it's still 100 to start. And then we know that 500 equals 100 e to the R times 5 power.
All
So
right.
you still divide by 100.
Okay.
And you get 5 equals e to the 5r. You undo both sides with natural log, or undo the e with natural log. So on the right, it becomes 5r. And then you
Okay.
divide both sides by 5. So your r here is the natural log of 5 over 5.
All right. So now I would put that into Desmos, right?
Yes.
That's going to be 0.321.
There you go.
Right.
Fantastic.
19.
Yes. All right. So the next two problems are going to require some graphing here. What I'd like you to do is go to Desmos and type in y equals 3x, and then hit enter and go y equals 3. In the exponent, you have to put an x plus 1 in parentheses. So I'd like you to graph both of those, and maybe you'll see the answer. It should be clear, but sometimes with exponentials, it's harder to see than just with, say, quadratics, where the movements are very, very calculated.
All right. Let me just go to the Desmos graph.
And keep in mind the words that you're seeing in the answers: up, down, left, right.
Oh, dear Lord. 3. 2, 2, 2, 2, 2. So it's like it's to the right.
Try to think about the order though. It's the original to the new one. So think about, I don't know what colors you've got on your graph, but make sure you're going from the original to the new one when you say it's going right. Is that what you really mean?
Okay. So both of mine are in red and blue. Like the red's the newer version of the graph, and the blue one's the old one.
Okay, so from blue to red, is it really going to the right?
Hold on. No, it's going. They go from the left.
It's a shift left.
Yeah, it's shift left.
You weren't wrong, but the order matters. It's like, well, is it?
Is it really?
Yeah, I mean, it depends. If you're looking at someone and you say left, they think you mean right, and if your right is their left, so it's all perspective based. It all depends on so. All right, we will for sure be getting done with 20. That's good news. We'll be able to get get moving onwards and forwards on this. This one, though, again, requires you to graph. So if you could go to your Desmos and graph this for me, please.
Sure. All right.
So
Okay, so
you
I
should see something like this. The question is, where is this line? Which I know isn't drawn on your graph, but like, what does it look? If you maybe trace along the curve, what's the X values along here? What are they getting really close to?
the negative.
The X values. Like if you put your cursor right there, what's the X value? And then you keep going down, what's the X value? It should be getting really, really close to a certain number.
Like negative. I don't know, man.
The X value. You keep giving me the Y value.
Oh, sorry. It would be 2.
Yes,
So the answer would just be B.
it is.
We did it. We finished in time too. We did.
Yeah. All right, we'll go ahead and stop.